Hello? 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 Okay. First of all, you guys can ask me any questions you have through the chat window, and also if you want to talk, let me know so that I can give you the right so that you can talk. I just started recording, but I'm not sure if it's actually working. In any case, let's get started here. So first of all, I want to make sure that you guys get a chance to read the first announcement. So essentially that I want to say is I hope that you guys got a chance to read the course syllabus. And also another thing is we probably need to go over the first week material very briefly today, so that I hope you get a chance to read. If not, I hope you can read later this week, by the end of this week, essentially only 3 or 4 weeks away, 3 or 4 days away. But the good thing is the first week, the material is not a lot, so hopefully it's better. Just a question for you guys. Did you guys actually have a book already?
No.
Some of them you already have. Any special reason that you didn't get a chance to get a book yet? Is it hard to get, or you got the syllabus late? Or because we actually apologize on our end because we only published the site since Tuesday, so I know you guys probably didn't know what to look for yet.
That's funny. I didn't see anything on the site until this morning.
Oh, until this morning?
Yes.
Oh, okay. So it's even later. So what happened was, because it was summer, so everybody is kind of crunching at the end of summer. So apologize for the delay. But let's first of all let's get started. I'll introduce myself very quickly, and then we can go over the syllabus together. Okay. So. This is a bio of myself, and essentially that's my picture. Okay, so I actually currently I'm working at BlackRock and working on market-related products, fixed income related. So I'm not sure if any of you are familiar with finance or financial products. If you have any questions on my background in this regard, we can definitely. I'm happy to further talk about mortgage-related models, etc. And previously, I have been working briefly at Goldman Sachs and also a couple of years at Morgan Stanley on fixed income related products as well. And but before that, as Association Shares, I was actually working as an optimization analyst. So I'm not sure how much you guys know about optimization, but basically this course is about optimization. So and before that, I finished my master and PhD from Rensselaer Polytechnic Institute in operations research and statistics. So that's briefly my background. So if you have any questions, feel free to ask me. Anything about work, about your project, or about your study, feel free to ask me questions. And another thing is regarding this course. So I'm not sure how much background you have on optimization, on some of the methods that we are going to discuss in this particular course. So if you have anything or any questions about the material, feel free to contact me either through email or through the Blackboard system in the the discussion board because you guys are the second year students, so I'm sure that you know how to do this, which is definitely a good thing. Okay, so any of you have any questions? If not, I'll just continue with the syllabus. So you can see my screen, right? Okay, good. Rohan responded yes, so it seems like everybody responded yes. Okay, cool. So let's take a look. I hope this percentage making sense for you guys. But I guess so. Okay. So it's called, the course itself called Mathematical Modeling Techniques for Data Analytics, and we are using fundamentals of computational mathematics and also statistics and probability in addition to those two, and also information systems as prerequisites. And mainly, I think it probably makes sense if you have had statistics and probability before this. Even if you didn't take this particular 606 yet, we could, at least if you had some exposure to statistics, that would be helpful. Okay, so what are we going to cover in this particular course? So as you can see here, we're going to talk about system optimization. So mathematical modeling itself is actually still also considered as optimization. So in optimization, there are a couple of branches. One of them is called system of differential equations, and also linear and nonlinear programming. In addition to this, we have other methods for optimization, and integer programming is another major branch for optimization. Of course, there are something called heuristics, such as generic algorithms and simulated annealing. These are all heuristics methods for optimization. So, but we're not going to talk too much about heuristics. Probably even not, just a little bit, I believe. But we mainly focus on the optimization methods. Okay, so that's the course description, and I hope that you would be able to learn linear programming models and theory, understand simplex method, and apply to LP models. So what is the LP, linear programming per se? I'm going to discuss as the course goes along, but in general, as you can imagine, okay, yes. So Rohan has a question, says, when you see optimization, what exactly is being optimized? So for this particular course, it is a math-oriented subject, right? So essentially, we are using mathematics to solve some particular problem. It can be any problem optimization-wise. For example, if you want to, if this is a factory, they want to make a decision that how to best use the wood, WOOD, the wood products that they have, and they want to make a decision on how many chairs to make and how many tables to make with 300 square feet of the wood that they have. So they want to decide how to cut the 200 square feet into pieces so that they can make, maybe the decision would be 20 chairs and 5 tables. And then because 5 tables each of the table can sell X amount of money, but each chair can can be sold for Y amount of money, so that they need to make a decision on how much of the wood should be applied to the chair making and how much of the wood can be applied to the tables. So that's a basic example. But let me search and get you some more specific examples here. Let's just quickly say optimization example. Let's use Wiki. So mathematical optimization. For example, this says, okay, if I have some area, some particular function that I want to optimize, this function is negative x squared plus y squared plus 4, and then where can I find the global maximum? This point is the global maximum, right? So from 3D dimension, it's 0, 0, 4. So this is one of the example of optimization. So it's called mathematical optimization. It's also called mathematical modeling, as you can see here. Mathematical programming, optimization, mathematical optimization, and we also call it math modeling here at least. And let's say another example here. So for example, I want to minimize this x squared plus 1 with some specific region, a set of real numbers, and where can we find the minimum? As you can see, right, we know this minimum should be x equal to 0, it is 1, right? And of course, it's not going to be that easy like this example, but that's the idea. That's what is optimization in general. Rohan, did I answer your question? Okay, cool. So seems like you have a good understanding here for this particular question. Let's continue with the syllabus. So essentially, it's a linear programming. That's what I was saying. So let's get a very brief overview of linear programming first. So as we can see, okay, the constraint here is linear, meaning that if we have a particular area and objective function, I'm going to explain this later. It looks really complicated here, but it's really not. In reality, it is not. So this is one standard form for the linear optimization. Say, suppose that we want to maximize this. Assuming this is the example that I was saying that for making chairs and tables, and C1 is the profit that you can make for X1 amount of chairs, and C2 is the profit that you can make for X2 amount of tables. But you have some constraints, right? Because maybe you don't have enough wood that you can use to make the table and chairs. It could also have some other constraints, such as you don't have some other resources that you can use. So based on all these constraints, plus this optimization objective, and some other conditions like non-negative variables, so based on this particular function, how can we find what's the best x1 and x2 so that this function can be maximized? And because the function itself is all linear, that's why it's a linear function. And we call it as linear programming. So essentially, as this being said, that's why we have nonlinear programming, meaning that the objective and all the constraints can be either one of them or both of them can be nonlinear. It has quadratic form or has log linear, not log linear, it's logarithm, or some other very weird functions that need to be optimized. So that is linear programming, a very brief overview of linear programming and math programming in general. And also here, there is another thing called integer programming, saying that instead of my decision variable here, again, if x1 can only take the example that I just gave for chairs and tables, they cannot be a fraction, right? So x1 has to be an integer, and x2 has to be an integer. So the question would become a little bit more complicated. So that's why it's called integer programming. That's another type of problem. And for integer programming, one of the famous methods would be branch and bound technique. And the next thing would be quadratic and nonlinear programming, how to solve second-order condition and apply the quadratic programming. So if you remember in high school, you actually learned how to find the maximum or minimum of a quadratic function. That itself is a nonlinear programming problem because that problem, only difference is for that problem, it doesn't have any constraints at all. Assuming that if you have a quadratic program and then you have some weird constraints somewhere that you cannot take some of the values, then it would be a different problem, which we can try to solve here in this class. And one of the solution method is deepest descent method there for a nonlinear program. So and the good thing is that you don't really need to solve them by hand. You can use some optimization tools to solve them. Of course, for linear programming, I hope you can understand how to solve it step by step to solve some two variables or three variables, two decision variables or three decision variables problem. Okay. So do you have any questions so far? If you guys, you can either speak or type if you have. Okay, Santiago just arrived. Welcome. We are going over the syllabus, so if you have questions, you can feel free to ask. Okay, seems like no one is having any questions so far, so let's continue. So what do we want to achieve by learning this course? Why is you kind of think, kind of probably asking yourself, why is it important to have this particular course in this whole sequence of the data analytics or data science program? So one thing that you have to understand that is there's many of the mathematics problems are optimization problems, including some of the statistics problems. For example, in the problem of I'm not sure if any of you have exposure to linear regression. If you do, let me give you an example. So the concept of linear regression is not that difficult to understand, right? So we have a bunch of observations, and we're trying to fit this linear line. And where should this line go to? It could be somewhere here, could be somewhere there, but it turns out to be this will be the best. How to measure this is the best? That is only because we one of the measure of the fit is to see that the error is the minimum. Error between the prediction versus the actual observation. We actually are going to cover this subject in this particular course, although if you didn't have any exposure yet. But that's the reason we're going to cover this. And another reason that you probably realize that you're going to learn something that's really advanced called machine learning. Many of the machine learning algorithms, the basic algorithm that it is trying to use is optimization. So many of the machine learning problems itself are machine learning problems as well. Or I should say many of the machine learning problems are actually optimization problems as well. That's why it's very important to learn, at least have some exposure on what it is and why we're learning this for optimization. Okay. So continue with this. Such as gradient descent. Actually, can you, Aaron, can you just ask this question? I didn't get what you mean.
I was just saying that gradient descent is an optimization problem, right?
Gradient descent is, I would rather say that it is an optimization technique to solve an optimization problem.
Right.
Yes.
Okay. Yes.
Yeah. Okay. Aaron's question, I think you guys heard that, so that's cool. So continuing with this, as I mentioned here, it is foundation for some problems that we will come across in linear regression, machine learning, and data mining fields. With understanding of math modeling techniques, IS and data analytics professional would be able to solve many more real-world problems more effectively and efficiently. So that's why we are learning optimization in this particular program. Okay. So now let's look at the assignments and grading. So here I said I wish you can participate online discussion in the Blackboard, which is in here called discussion board. In this discussion board, I have week 1 discussion, for example. I'm going to provide one specific topic each week. For example, this week's topic is not here yet, but I'm going to add later today, which would be what's your understanding of optimization and how much exposure do you have. If you don't have anything, you can say, I don't have any. I heard of search engine optimization, whatever that you think it makes sense that we can discuss so that I can get an idea of your background, so on and so forth. And maybe week 2, we're going to discuss some other things, maybe some other specific data science or statistical analysis type of discussion topic. So that's the idea. And I hope that what I said was please actively participate in the online discussion each week about the homework, some discussion forums that I provided, or some project topics that I'm going to provide. Please have at least one substantial discussion. Express your views on a topic in discussion extensively. I'm saying that maybe 5 sentences, but at least you express a view there. It's not like, oh, this homework is really difficult. That's not going to count for a substantial discussion. Okay, and this accounts for 14% of your grade, and I hope it's not too difficult because it's only one. I just hope that you guys can be engaged more in discussion in the course itself. That's why I have this piece. And in addition to that, I have assignments. It looks like a lot, 14 of them. I just hope that because for this course, I don't have any final exam. I don't have midterm exam, and assignments and project will be the major ways for me to measure how actively you guys participated in a course. So I decided for 14 homeworks, essentially meaning each week you have a homework due. Although it sounds a lot, it is really not if you spend a couple of hours to study the material. Okay, and for the assignment, it is always due at the end of the week, which is the Sunday. For example, for this first week, it would be we already have a homework due on Sunday, 11:59, but I know it's the first week. If you have some other circumstances that you're saying that you are too busy, but I'm going to definitely submit by the end of next week, it will be fine as well, especially for this first one. But for later ones, I hope you guys can make it by the end of the week. If you can't, I hope you can at least communicate with me 3 or 4 days earlier. I actually don't think it's a good idea to delay the homework because it would pile up, which actually make your study more miserable. So it probably makes more sense for you to follow the schedule, try to finish it on time, and to ask me questions or ask the fellow students any questions, and we can discuss. Okay, and next thing that I want to discuss is the project. So for the project, I have already attached what the project is about, but it's probably very difficult for you guys to understand what it is yet. But the idea is I have a couple of deliverables. One is project proposal draft, which is by the end of week 9. By the end of week 9, which is already October 26th, which is almost 2 months from now. And you don't need to write very extensively. You can write it within a page or half a page. Just let me know what you are going to work with and who are you going to work with. Because this project is a team project. It's a project that you can work with another fellow student. So essentially, it's a team of 2. Of course, if we only have odd number of students, we'll figure out one of the team probably needs 3 guys instead of 2. And after this project proposal draft, now we can discuss a little bit more individually with each team. I'm going to talk to you and understand more about your project so that we kind of try to make the project proposal work, which would be after 2 weeks or after 2 weeks of the first deliverable. I hope you can have the final project proposal, which is only less than a page, which is count 10% of the project grade. Another thing is the project proposal draft also accounts for 10% of the project grade. And we are going to have a project presentation, which is December the 11th, which is the 15th or 14th week, I believe, of the course. So that in that week, you need to submit the project presentation slides. As a team, of course, I think because I didn't set up the team in the Blackboard system yet, you guys probably have to submit each one individually. But if someone is working with another student as a team, you guys can, each of you can submit one version. I hope both of those 2 are identical. Then I would know who you guys are working together. There are more details regarding this, how you are going to submit, and how you should be, some guidelines there on the Blackboard. Later you can take a closer look. And then the session of that day starting at 7:45, I hope you can submit the slides by 7:30 so that I can put them together. You guys can present the project. And those 2 things account for 30% of project grade. And after that, the last thing would be final project report, which is December the 14th. So here, essentially, which is worth 50% of the project grade. But as you can see here, I actually give you a couple of more days after project presentation. I just hope that if you don't have enough material to put down on the paper yet, you can do that after the presentation. But the presentation, hopefully you already get the majority of the meat of the project report done. Okay. So this is the same quality of performance, how you can get an A minus, B plus, C minus, so on and so forth. That's the percentage that the university are using. And I definitely can curve. That's not a problem, but I just hope that as long as you guys work hard, there's no problem to get a good grade, hopefully. And this is a required textbook. It's not hard to search. Let me quickly search that you guys, if you didn't have the book yet, you can get a sense on what book. Yeah, this particular book, it wasn't this expensive. Let me say which version. Fifth version, 5th edition, and okay. It wasn't this expensive earlier. Especially, I think you guys could buy a student version, which is much less expensive than this number. It's below $100, I believe. Yes, this is the fifth edition. So this is the 5th edition. So this is the book I'm going to use. Yeah, I think there is a student version somewhere, so that you guys can do some search, and you guys can share where you bought the book as well, if you can, from some other fellow students. And I have another supplemental text, which is an online book. This is a professor in Carleton University in Canada. He wrote this book, but I'm mainly using the other book, the required book here. So this is only a supplement. One of the major chapters, integer programming, will be from this supplemental text. The good thing is it's online. We can just use it from there. Of course, if you want to refer some other topics from this book, it would be nice as well. So we're going to use R for some of the optimization, but the programming part for this particular course is not going to be a lot, mainly because it's more like applied mathematics course. So we probably do some crunching numbers by our calculation by hand in terms of some, instead of using the software. But I'm going to introduce pieces of the optimization packages from R so that you guys can get a sense on how it can be used later on when you do some practical projects at work or for some other courses. So this is my contact. Again, feel free to send me an email anytime if you want to. And this is the topics that we have here. So for example, for week 1, August 28th to 31st, homework 1 is due, and Sunday 11:59 9 p.m. And I hope you can do one Blackboard discussion, so on and so forth. And so this is the whole thing. Essentially, I already discussed everything there previously on the syllabus, but this is the idea here. Okay, even here, for example, week 11, I want to look at final project proposal due. Okay, and week 15 is final project. Okay, so on and so forth. And in the syllabus, I have another that is cost project, and it has 3 options. We can discuss more when the time is approaching the first project proposal class. So I hope you guys can at least form the team by end of the week 8, which is October 19th. Meaning you just let me know, I'm working with Aaron, or I'm working with Rohan, so that we can continue with the course. that's pretty much it for the syllabus. So I think it's a good time for you guys to ask any questions, and then we can quickly go through the first week's material. You guys have any questions? Okay, Aaron said good so far. Anyone else? You guys have any questions?
For this week, what will be the homework? Is it which is due by this Sunday?
Yes, it's actually due by Sunday, and we can go over that very quickly. Okay, actually, there's another thing that there's a video that we Paul asked us to have it on the site, which is the introduction of the material for the whole course. So there's a video there. You guys should feel free to read, to watch it. It's around 15 minutes long. Some of the information is actually here already. And what is the math modeling? Why are we going to solve it? So it's more specific for explanation of the course. So I hope you guys can take a look. That's the thing. So let's say first week. Actually, before we go to first week, we only have, yeah, it's okay. But this is, I want to explain what's here. I'm sure you guys have seen this previous video, which is a curriculum map. Yes? Okay. So if you guys have already seen this, so this is where we are, right? So IF606, supposedly this math modeling should have this as a prerequisite, but it happens that many of you guys are probably taking both of them at the same time. First thing is what we're using here in this course, we have a fraction. Beginning of the piece would be helpful. Beginning piece of the course from probability and statistics would be useful for math modeling. So it's fine for you guys to take those two courses together. And so this is where it fits. And then the reason that we have this is because later on when you do data mining or machine learning, you definitely should understand some of the math modeling concepts. That's the reason we have it here. So hopefully you can understand more about why it's useful in the curriculum later after we have more here. Okay, apparently I didn't. Oh, yet another thing before I start the section for, the lecture for the first week. That is, I want to talk to you about what's out here in this black box system on this particular course. So you have my contact here, and also if you have any questions, you can click Ask the Instructor. I'm sure you already knew. Someone didn't mute? Oh, okay, I'll mute. Okay. And in the weekly materials, I think it's worth looking. I have all the slides together as one file, so you can download. Of course, you can go to each week and get each week's material as well. And also, I have a cost project section. In this cost project section, just quickly go through. I have just discussed, as we just discussed, I said I have 4 submissions. Each one has like 10%, 10%, and 30% and 50%, so that you can follow through in this section. And if we go back there, and our material, and then just week by week, right? So on this side, you know there's a discussion board. We can talk about each week. Week 1 discussion, week 2 discussion, so on and so forth. Okay. And meetups, just the information on some useful information. One is this GoToMeeting information. The other thing is about some local meetups. I hope if I have some idea. Of course, you guys are not in New York City area, so oh, it's actually everyone is actually they muted themselves. So, Hassan, can you hear me?
Yeah, I'm here.
Oh, okay. Because I heard some type of background noise. I wasn't sure if from you, maybe from some other guys. But that's
Yeah,
fine.
I believe as a practice we used to mute everyone in the past.
Okay, I was actually trying to, but seems like because everyone already muted themselves, that way if you want to talk, you can just automatically unmute yourself. Okay? Good. So that's great. So if we continue this that's all the discussion, meetup, regarding meetup, so I'm going to provide some information, although you guys are not in the New York City area, but there are some useful discussion on meetups if I saw some, which also very related to good stuff. If I found something interesting, I'll share it there. And now let's go to weekly materials. Go to week 1. So for example, I have an intro video, which is like, for this week is around 10 minutes. But for some other ones, it can be a little bit longer or a little bit shorter, around 5 to 15 minutes. So you can read. Hopefully that can help you to understand the material. And then I have each week's material, and we can go to week 1 discussion board from here as well. And this is the homework. So let's take a look. Let's take a look at the slides before we go to the homework 1. Okay, for week 1, before we started, I said, okay, chapter 0. Why I say it's a chapter 0, I just hope that you can understand some of the basics about the fundamentals, prerequisites that we need for this particular course. So at the Appendix C, page APP 12, you can see some review of integration techniques. Some of them will be used in this course. That's why I hope you at least know where to refer to those materials. Or if you didn't have any exposure to this, you need to read that section and ask any questions if you have. And make sure that you are comfortable with these math techniques, and also ask any questions anytime. And this is the material for Appendix D. So please review before you actually start anything. For Chapter 1, Chapter 1 is actually relatively easy because some of the material you already know. For example, difference equations, I'm going to explain what it is, and also how to approximate change with difference equations, and some other topics such as solutions to dynamic systems and systems of difference equations. So as an introduction, why do we need math modeling? So we have real-world data. We are trying to simplify those data to build a mathematical model. So essentially, model itself is a simplification of the real-world data. And then you can do some analysis based on the model and try to do interpretation to do predictions and explanations so that you can use the math model to verify whether it makes sense. So that's what is the modeling process. So what is how to model a change? It's relatively easy. The future value is present value plus the change. So this is in chapter 1. So you can take a look. And what if we have multiple changes, right? Nth difference. This essentially is high school concept. How we can get delta an, right, which is an plus 1 minus an, and also we can get an plus 1 from a0 by if this the difference is a constant, right? Okay. So here it's the same thing. It's just a graphical explanation. At step n is at an, and step at time n plus 1 or step n plus 1, the value of the function is an plus 1. So how we can model this delta an. And this example this is an example in a book, which is saying that how can we model the mortgage of a home, and then how much payment we need to pay, given that if we have an initial layout of some cash for equity for the house. So I think you guys probably need more time to review that. For chapter, it should be very quick, around. If you read carefully, less than an hour or two, you should be able to finish the reading, and homework mainly based on what's in the textbook. So, and here it says how to model change with difference equations. So essentially saying that how can we use a sequence of functions to model a system. So here, discrete change from time to time, what's the difference, and also versus continuous change. Many of these are only concepts trying to explain some of the very basic ideas here. So essentially, modeling per se is really not a lot. And also another example how to solve it, and this particular example here says the observation is dotted line, dark dotted line, and predictions is circled. And you can see it's really very close for this particular model. And how you can use dynamic systems, how to look for a pattern, and conjecture, test for conjecture and conclusion. And linear dynamic system, and the linear, this is very similar to what we learned in high school, right? Nonlinear systems, meaning if x, this is x, this is x, next value would be a function of x squared instead of x. So as I said here, there are very good examples of system of difference equations on page 37 to page 52. And I hope you can read these problems. And then after reading them very carefully, the homework should be very self-explanatory. Yeah. As an introduction for the first week, actually I'm not going to spend too much time on the lecture itself. And also especially the first chapter is really relatively easy and fundamental. So this is the homework. So for the first week, you have 4 problems to solve. As you can imagine, all these 4 problems are mainly from the examples. So if you read the material, you definitely should be able to solve those 4 problems. And as a follow-up for later on sections, I'm going to spend more time to explain actual algorithms or actual methodology for each topic. But still, I hope that you guys can actually do some reading or do some at least the preview of the course before you actually come into the lecture, because otherwise it might be difficult for you to understand a lot.
Do you mind if I take a shower? I have to shower.
It's difficult for you guys to understand all the material. I just realized that we need to because we only meet the other week, meaning we actually have to cover a little bit on the second week as well. But you guys didn't even get the book, so let's see. But if you can finish the homework on time for the first time, even for the second week, let's try to. I'm going to give a little bit more time for you guys. Okay. For the second week, it's I have to quickly go through, but the idea is how to model problems with proportion and geometric similarity. So now actually you can, as you can see, it's far from what we are going to really learn, which is linear programming, nonlinear programming. But at least we're going to understand some of the basic math modeling techniques here. Yes, I hope you guys can go through this whole process and understand. So this is an introduction why we want to use math model versus real system. I'm sure because every one of us is a modeler here, I definitely think you guys should be able to understand why the fundamental idea about this. So I'm going to quickly go through. You guys should read this and also read the chapter. And homework for the second week has 5 problems. It's all not that hard. It's all based on textbook. So that's the reason I just mentioned that. I hope you guys can read the textbook and also ask some questions and we can discuss. I think that's pretty much everything for this week and also as an introduction for the course. So just want to see if you guys have any questions or have any comments or anything, feel free to ask.
I think it all looks really great. I'm really excited to learn this stuff. I think I don't have a lot of questions right now, but I'm sure as we all get into the assignments and the book and everything that's when we'll start to get more questions.
Yeah. Actually, before we actually start, I hope that you guys can give me a little bit about your background. But it comes in, it just occurred to me a little bit too late. But we still have Rohan, Aaron, and Pasang on the phone. So if you guys can at least introduce yourself a little bit, so that I kind of get a understanding of your background. And next week we can have more. The week after, we can have more classmates to discuss so that I can understand their backgrounds as well.
Right.
Yep.
So I'm Aaron Palumbo. I'm a mechanical engineer with Microsoft right now. So I'm working in the Surface group. I do tablet development. I'm kind of moving into sensors and aggregating sensor information and trying to make sense of that. That's kind of how I'm attempting to merge my background with the data analytics. And so I have a pretty decent math background, but it's been a little while.
Oh.
But
but actually, mechanical engineer, many of them actually do optimization as well. So
yes,
right, I'm sure you know. Okay.
Yes. Yep.
Good to have you here.
Thank you. It's good to be here.
Yep.
I'm Rohan. I am currently a data analyst at a nonprofit educational fund in New York City. We get grants from the government, and we use that to train healthcare professionals. I did mathematics as an undergrad at Michigan. And that's what kind of got me into the whole data analysis kind of thing.
Okay, I see. Good to have you here, Rohan.
This is Partho Banerjee, and I did my master's in maths pretty long back, almost 20 years back. And I have master's in business also. And currently I work for federal government and in a research and development wing. And I used to manage a couple of modeling tools which used to do deterministic as well as stochastic modeling. And that's where I got an interest to understand all this stuff. So hope I will learn a lot.
Thank you. That's great. Good to have you here in the class and in the program.
Thank you.
Yeah. Santiago, I just saw you just dialed in. We are trying to see if you can give us a little bit background. Each of you guys can give me a little bit introduction so that I can understand your background, and so it's easier for us to continue with the call. Okay, Santiago seems like not. I'm not sure if he is not connected to audio, so that's okay. So I think that's everything for this week as an introduction. Do you have any questions, any of you?
Not now.
Okay. So if not, we can just call it a day for today's session, and I hope you would enjoy the course. I also hope that you would think that you learned some from this course. And let's start the semester.
Great.
Yep.
Thank you very much.
Yeah. Thank you. Yeah. Bye-bye.
Bye.